104 mid-module check. So this is a set of examples that will help you prepare for that mid-module check. Number 1, decide whether each square root is a rational or irrational number. So remember, a rational number I can write as a fraction, and an irrational number is a decimal that goes on forever, so it does not terminate, and it has no pattern. So the way I would tell when I'm looking at square roots is if it's a square root, if it's a perfect square, and I can easily take the square root, then it's going to be rational. So for example, the square root of 9 is 3, because 3 times 3 equals 9. So since 9 is a perfect square, I can easily find the square root of 9 is 3. And so this is going to be rational. But if I'm looking at something like square root of 7, we could estimate that. We know it's going to be, if square root of 7 is going to be less than square root of 9, it'll be a little bit less than 3. But we don't know the exact value without doing some guessing and checking or without using a calculator. And so that's going to be irrational. And you're welcome to do that on a calculator. If I take square root of 7 on a calculator, I'm going to get a decimal that goes on and on forever and has no pattern. So let's look at the next one. Square root of 25 is 5. So that's going to be rational. Square root of 2. So I'm going to go ahead and do this one on a calculator to show you what I mean. When I plug it into a calculator, square root of 2 is 1.4142135562, and it just keeps going. That's just the places that my calculator will give me. So since there's no repeating pattern in this and it goes on forever, it's going to be irrational. Square root of 1 is kind of tricky. People want to say that it's irrational, but I can remember 1 times 1 equals 1. So the square root of 1 is just 1, and it will be rational again. I can always take any whole number and make it into a fraction. The last one, square root of 8, is really tempting to put down 4. So people sometimes confuse a square root with taking half of something, and they're really not the same thing. When I'm finding a square root, I want to know what number times itself makes 8, and there is no such number for 8. So that means the square root of 8 will be irrational. Problem 2. Write and solve each equation for x. So in order to do these problems, we really need to be thinking about those properties that we can use for exponents. So on this first one, I have 4 squared times 4 to the x power. So I need to remember what I do with these exponents to combine them together and get 4 to the 20th. So here I have 2 factors of 4, and I'm multiplying by x factors of 4. So remember, we're always trying to think about how many factors all together. So all together makes me remember that I'm adding. So that means I need to add my exponents. It means 2 plus x has to equal 20. And then I'm going to go ahead and solve that for x. So x equals 18. On the next one, I have 4 squared to the x power equals 20. So this means I have x groups of 4 squared. So I write 4 squared times 4 squared times 4 squared. I write that x times. And x groups of 4 squared makes me remember that I need to multiply. So that means I'll have 2 times x equals 20. And then I'll divide both sides by 2. And x is equal to 10. For the last one, when I'm working with fractions, I have 4 to the x power divided by 4 squared. So remember, we write out all of those x's, and then we can take away 2 of those factors by crossing them out. So that means I'll have x minus 2. Take away makes me remember that I'm subtracting. And then 4 to the 20th, I'm just using the exponent there. And then I want to solve. And x is equal to 22. On page 3, it says simplify. Write your answer as a power. So on this first one, I have 7 to the 9th power times 7 squared to the 4th power. So first we need to get rid of parentheses when we're simplifying. just like we do when we're solving equations. So this means I have 4 groups of 7 squared. So I'll have a 7 squared times a 7 squared times a 7 squared times a 7 squared. And I have 7 to the 9th out here. So this means I have 9 factors of 7 and then 2 more and 2 more and 2 more and 2 more. So I can add up all those exponents. So let's see. 2, 4, 6, 8 plus 9 is 17. So I'll have 7 to the 17th power. So let's go ahead and try the second one. 8 squared and then cubed. Cubed means times itself. I have 3 factors. So x squared times 8 squared, sorry. And then I have times 1 more 8. So then I want to think about how many 8s I'm multiplying out. The first 8 squared is 2 8s. The second 8 squared is 2 more factors of 8. And then 2 more factors of 8. And then that one lonely 8 by itself. So I have 1, 2, 3, 4, 5, 6. I have 7 factors of 8. It'll be 8 to the 7th power. The other way I could get that is just by simply adding up those exponents. 2 plus 2 plus 2. And then this 8 that's by itself, we have to remember, has an exponent of 1. 8 to the first power is equivalent to 8. So for the last one, you're kind of seeing what we need to do already. I need to go ahead and multiply these two. I'll have 9 to the 10th. And then I have times 9 to the 0. So there's different ways we can handle this now. I can add them together. 10 plus 0 is just 10. So my answer is 9 to the 10th. Or I can even remember that anything to the 0 power is just 1. So this is really 9 to the 10th times a 1. And anything times 1 is just going to be itself. For number 4, we're asked to simplify and write our answers as a power again. Writing it as a power just means I'm not going to plug like 5 to the 13th power in my calculator. I'm not going to write out some big long number. I'm going to have a number with an exponent. So in the first one, I have 8 factors of 5 times 2 more factors. I can go ahead and add those. I'll have 5 to the 10th. Same thing on the second one. 5 to the negative 8th times 5 squared. Negative 8 plus 2 is 5 to the negative 6th power. And I should rewrite that negative exponent as a positive, so I need to take the reciprocal. So remember, right now it's over 1. If I have a negative exponent, I need to flip that. So now I have 1 over 5 to the 6th. So we can change the sign on our exponent by doing reciprocals. On the last one, I'm doing the same thing. I have 8 factors times negative 2 factors. Add those exponents together. 8 plus negative 2 is 6. For 5, we're simplifying and we're writing answers without fractions. So in order to write without fractions, we may need to use negative exponents. So let's remember our rules for dividing. So sometimes we work with letters, it's very abstract. It's always good to go back to something we know. So if I have 5 to the 4th and I'm dividing by 5 to the 1st, how do I figure that out? 5 to the 4th means I have 1, 2, 3, 4 5s. I have just 1 5 in the denominator, so I can take away one of those factors, and I'm left with 5 to the 3rd. So I get that by subtracting exponents. The first one minus the second one, top minus bottom. So that means for this first problem for 5, I need to take negative b and subtract c. So I'm subtracting the one that would be in the denominator. So now I have a to the negative b minus c power. And we'll do something similar on the next one. I'll have a, and my top exponent would be d minus negative e. And again, whenever we have minus negative, even with fractions like this, even with exponents, it'll be plus. So we'll have a to the d plus e power. So we always want to make sure that we simplify that all the way. We wouldn't leave it as a minus negative. For problem 6, we are going to create a rational number between 4 and 5. Remember, rational means fraction. And we'll create an irrational number between 4 and 5. So remember, irrational means a decimal that goes on forever with no repeating pattern. So if I want to pick a number between 4 and 5, there's a lot of different numbers I could write down that would be rational. 4.5 seems like a pretty easy one. And I could even change and make that an improper fraction. If I have 4 and 1/2, 4 times 2 is 8, plus 1 would be 9/2. So that would be a rational number between 4 and 5. I could even write it as a decimal. I could write down 4.5. Any of those would be good answers. It doesn't say what form it needs to be in, just a rational number, and all three of those are rational numbers. You could pick 4 and 1/3. You could pick 4.99. That's still a rational number. It's a decimal that either terminates, or it has a repeating pattern, or something that I could just write as a fraction simply. For B, when I want to create an irrational number between 4 and 5, if I want it to be between 4 and 5, I'm obviously not going to start with 5. I'll start with the 4. And then I'm just going to write out some numbers and make sure that there's no pattern. So if I start with like 147, I wouldn't want to write a 147 again. All right, like 9, 2, 3, 4, 1. And then I'm going to make some dots to show that it goes on forever and it doesn't terminate. For our last problem, we're asked to simplify and then write our answer using exponents. So for this first one, 6 squared and then to the 5th power, I need to remember that I have 5 groups of 6 squared. So that means I need to multiply those exponents. I'll have 6 to the 10th. And for the second one, 5 to the 7th, then to the 4th power, again, we'll multiply 5 to the 28th. And then I can't put the 6 and the 5 together because they are not the same base. So I'm going to leave it that way. For the last one, I want to take this 4th power and distribute it to everything inside. I can distribute over multiplication, and same thing with the squared. So again, just like with solving equations, we're always trying to simplify and get rid of parentheses first. This will give me x to the 8th times y to the 12th times x squared times y squared. Now we want to take everything with the same base and put them together. So here I have 8 factors of x and then 2 more factors of x. So all together I'll have 10 factors of x, or x to the 10th power. I have y to the 12th times 2 more factors of y. So all together I will have y to the 14th. And that'll be my final answer on that one. Make sure that you are taking notes on these problems as you're going through and working them out and not just watching them. You are welcome in my class for these quizzes to go back and use your own notes that you have, but you can't do that unless you have notes.